Yeah, grand day, everybody. My name is Mohammed Yakini, and today I'm going to be presenting to you guys about data privacy for increased customer data protection. So before we get started, we would be walking ourselves through some of the content of today's presentation, basically. So in today's presentation, we are going to be talking about what is data privacy, the types of data privacy available, why we need to protect our data. We'll also be um, breaking down the misconception out there about data privacy versus data security. We'll also be walking ourselves through the techniques involved in protecting data, and hence would conclude this presentation. So to start with, would like to know what is data privacy. Most of us might have heard the word data privacy or data security, and it gives us this regular definition as to what data privacy is. Obviously, we are trying to protect something. Obviously, we are trying to, be private about some information, right? So data privacy, which is also called information privacy, generally means the proper storage, right? The proper access, retention, immutability, and security of sensitive data. Also, the ability of a person to determine for themselves when, how, and what extent personal information about them is shared, or these personal information are being communicated to others as well. So this particular personal information that a person needs to determine how and when or what extent it should be shared, are often called PII, which are personal identifiable information. And this information could be names, it could be health record, social security number, credit card numbers, and financial data. In fact, even real world behaviors. So we have different types of data privacy, right? Or if it's best to say, we could categorize data privacy into some sort. So it's also helpful to list the category of data that are exempt from privacy issues. There are two major categories. We have the non-sensitive PII, and we also have the non-personal identifiable information, right? So starting off with the non-sensitive PII, these are information that is already in the public record, such as phone book or online directory. So we have phone books or online directories which are already in the public, right? And they have information about phone numbers and all of this. We also have the non-personal identifiable information, which is the non-PII. These are data that cannot be used to identify a person. Example includes device ID or cookies. So sometimes you might see some data that includes devices, people's devices ID or cookies. This kind of data could not be used to identify a person because if you were to read out 100 individuals' devices ID, you wouldn't be able to relate it to who that belongs to. But however, some privacy laws hold that even cookies can be considered personal data. If you are paying attention closely, I mentioned some non-sensitive PII, which are in the public record, such as phone book, online directory. But we have seen in recent time that some privacy laws even says that some data should be considered personal. Why? Because of how vulnerable sometimes we might be in the world today, just like we have phone books and online directories. There are a lot of phishers and a lot of scammers out there that might want to make use of this information in the public record or online directory to spam people, right? I'm sure most of us might have experienced this one way or the other. When you get, unnecessary messages or spammy phone calls from some individuals that you don't know and trying to sell you some bullshit. But nevertheless, these kind of data could be considered personal data, right? At this point, we had sometimes where privacy laws says that cookies could even be personal data because they can also leave traces that could be used in combination with other identifier to establish a person's identity. So cookies, for example, could be cookies from your browser, or cookies from some other information that you might have provided. And this could be traced. It could be traced to the location attached to those cookies and whatnot. It could be anything, right? And they could also be used in combination with other identifiers to establish a person's identity. And the moment they establish the identity of that person's information is no longer private. So these are the type of data privacy. Moving forward, we'd also want to know the reason why we need to protect data. So digital transformation is profoundly altering every aspect of how today's business operates. Today's business, operates and even competes, So enterprises are producing, they're storing, they're manipulating an ever increasing amount of data, right? So how do they increase this amount of data, right? By their engagement with their audience. So it could be in any industry. For example, we have the e-commerce industry that might have a large set of audience. And engaging with this audience, you then need to be producing, right? Storing data, of billions and millions of people, right? So with this increase in the need for data governance, right? Because with this ever increasing amount of data, we need to govern this data. We need to make sure these data are put to use in the proper way. We also need to ensure that this data, it's been monitored. So hence the need why we need to govern our data. So keeping private information and sensitive information safe is very, very paramount. If items like financial data, healthcare information, and other personal consumer or user data get into the wrong hands, can create a very dangerous situation, right? So the lack of access control regarding personal information can put individuals at risk for fraud and identity theft. Additionally, a data breach at the government level may risk the security of the entire country. And if one knows or if one occurs within your company, it could make your proprietary data accessible to a competitor. So usually we could then see the adverts of data breach, right? For example, in scenarios where it could be government data, right, which might put the security of the entire country, into the wrong hands. It could be in your organization, it could be in Bincom, right? And these data could also be accessible to a competitor. So a competitor might be there rather to scout for information about your business, trying to cook up your strategies and trying to determine what makes you stay relevant in the market. So these are why we need to protect our data, right? Because of security sometimes, because of data breaches that might give other third-party access to your data, right? Obviously, we know how some data could be sensitive. Data like financial data, healthcare information, and some other personal consumer user data, basically. So moving forward, would like to know what the difference between data privacy and data security, right? These terms, companies or organizations use these particular terms, data privacy and data security, interchangeably. Sometimes you hear it's data security, and sometimes you also hear it's data privacy. Well, actually, they are not the same. Data privacy is a branch of data security mainly concerned with handling data. So we have data security and also have a branch of data security, which is called data privacy, right? So in data privacy, it revolves around matters such as content, the data you're collecting, the regulatory compliance, and all of those. Mind us, these days, we now have regulatory compliance when it comes to data, right? One, it could be how an entity protects data when sharing to third party. When this ever evolving world where we need to share data, and to third parties, and they make use of data to make sense of their solution, and to extend the awareness of ours, right? So how we protect data when we are trying to share to third parties is data privacy, right? Because we are trying to be aware of these data that are private and we protect them, right? We also have regulations such as NDRP, which is the Nigerian Protection Regulation, right? So there are different regulations that spans around the world, right? We have regulations in the Europe, we have in the West, the United States, and these regulations are to be adhered to, right? Solutions, companies, organizations that makes use of data or personal user information, such as solutions in e-commerce, for example, solution in the financial industry. We now have them in so many fintech companies where we have they scoop out information about you. These information that they scoop out about you needs to follow through all the process. It needs to be, in line with the regulations such as NDRP. In situations where they are not in line with these regulations, you could be sanctioned. I will not be going into detail as to what are the rulings when it comes to regulations by NDRP. But these are the standards when it comes to data privacy. So that's what data privacy is. But data security in its sense concentrates on keeping data safe from attacks, from hackers, for example, right? It's the entire data security, right? If you could remember, we said data privacy is just a branch of it, and it's only concerned with handling of data, right? But data security is just like the full package, right? It refers to the process and the action that protects data from unauthorized access, corruption, and the likes through the data science lifecycle. So moving forward, we understand why we need to protect our data, some of the types of data privacy out there, and as well what data privacy is. We then want to know, what are the techniques that are involved in data privacy? So the identifying data using data privacy technique addresses the friction and risks around using sensitive data. And these, could enable data scientists to minimize the time collecting data and are allowing them to spend more time running and analyzing data. So just like we might know or not, data scientists spend, a ridiculous amount of time trying to, to make sense out of data, right? So with these data privacy techniques, right, and the risk attached to it when we are working with sensitive data enables data scientists to even minimize this time spent in collecting data and allowing them to even spend more time on analyzing these data. So different privacy protection techniques offer different protection level in data science. It is essential to know and understand how they work, depending on the nature of the application and the data. So you could choose any of these techniques, and we have a whole lot of them. But today we'll be talking about some, most effective ways, to protect our data, right? So one of the very most guaranteed way of privacy is anonymization, right? So a way to guarantee the privacy of personal and sensitive information is to anonymize it. So anonymization refers to the process of irreversibly transforming data to prevent the re-identification of individuals. So meaning, for example, that if a company releases an anonymized data set, it's theoretically impossible to re-identify a person from it. Anonymization represents the highest form of privacy protection. So in data science, we have a couple of packages that we use to anonymize data, one of which is called Faker, right? So Faker is a Python library. For those of us who does not know what a library is just a collection of modules. And modules, these are collections of functions and classes that enables us to achieve, a task. So Faker is a Python library capable of generating fake data, including names, IDs, numbers, categories, and more. So here's a code snippet to implement anonymization using Python, for example. Just like we have on the left-hand side, we import this Python library called Faker, and we'd also import pandas, which we make use in data exploration. We then have to initialize a client for Faker, right? And we have to seed these clients for 4,321. Then we move forward to create a list of fake names. So we create a list of fake names using the Faker library, and we can store this list of fake names into a data frame, more like a mini database, where we'd have it nicely imputed into columns and rows. We could then move forward to further using this Faker to fake out, student information on this particular table, right? And on our right-hand side, we can see that we have an entire column with the names of students available. But on the right-hand side, we also have another column that has new students' name. And these names are just fake names that were generated by this particular Python package. And in most cases, we make use of these fake names instead of the original ones. Mind us, this particular package can also reverse these fake names back to the original ones. So this is just a way of anonymization, which is one of the most effective way of or effective means of privacy protection. So moving forward, we'll be talking about data masking and pseudonymization. So these processes aim at protecting data by removing or altering its direct, sometimes indirect identifiers. So here are separate or several techniques to produce pseudonymized data. So we have encryption, which most of us might be familiar with. I know for some themes here, who really work with databases, we have sometimes that we might want to save passwords and would have to encrypt them, right? Using a cipher protected by an encryption key. We also have shuffling, right? Just scrambling data within a column to disassociate its original order, right? So we might have a column just like we have in this previous image, and we might just disassociate this column by interchanging all of the information, randomly. So we don't know if Brian comes first or if Brian comes last, or if Amanda comes fourth or James comes fifth, for example. We also have suppression. Suppression is nulling or removing from the dataset sensitive columns. So we have sensitive columns, maybe like the phone number columns, email columns, or bank account columns. And we can remove from the data sets, right? Or we can null them, right? We can change all the figures to null, and nobody knows what information is being stored on that particular column, right? We also have reduction, right? Which is masking out part of the entirety of the column's value. So pseudonymization of data requires the use of a package that provides helper function called gocept pseudonymize. So pseudonymize data like text, integers, email addresses, or license tags. Here is a cool example of how to implement that using Python. So using this gocept pseudonymize, which is a Python package as well, we'll be able to pseudonymize text, right? So just like we can see the first two lines, we have to pseudonymize a name, right? And we pass it a key called secret, right? So this name is Vimladil, and Vimladil can be pseudonymized and be changed to a pseudo kind of data, which we might not understand, just like you can see on the right-hand side. We could pseudonymize street names or street addresses, right? Which generate a fake or a pseudonymized, street address for us. Could also, pseudonymize emails. This is an example of an email which could be transformed to this. Could also pseudonymize phone numbers, and here we have the phone numbers that have been generated, the pseudo phone numbers that are generated. Moving forward, we'll also talk about the last way of privacy protection, right? So instead of masking our original data, just like we do with pseudonymization, or instead of generating entirely new fake data, we can generate a completely new artificial data, right? So a machine learning model helps create this new data set that mimics the statistical properties of the original data. So the original data has some sort of statistical properties. So in this situation of synthetic data, we'll be having or be creating a new data set that mimics, these statistical properties of the original data. So we have what we call SDV, or synthetic data vault, which is a Python package to generate synthetic data based on the data provided. So you'd have to provide a data set, an original data set, and this particular package will generate a synthetic data based on that data that you provided. So the generated data could be in single tables, they could be in a multiple table, or they could be time-based or time series-based formats. So it generates synthetic data by applying mathematical techniques and machine learning models, such as deep learning models. So this is an example of how synthetic data are being generated in Python using the SDV Python package. So we can see that we imported pandas. We read out a data that was hosted in a CSV file called horse, and we're also able to use a method in the SDB package called Gaussian coupler, which makes use of the mathematical concept or makes use of mathematical techniques, right, to generate this data. And we can see that we then fit in this data to our original data, and hence it generates a synthetic data based off data that we provided it with. So by my right-hand side, you have the original data and what it looks like, right? So below, we also now have what the synthetic data looks like. If we were to look closely, we then see that the synthetic data is almost the same as the original data, but not entirely. But with entirely new figures, new text, new not a number, any, and the likes. So this is how to generate synthetic data and make use of them instead of the original data. So moving forward, we'd like to just briefly talk about some real world cases of data breach, right? So we have the OkCupid data release, right, which was a data breach that happened sometimes back in 2016. So Emil and Julius Tapberg of Denmark actually shared a data set on the open science framework that included information of over 70,000 members of an online dating service, OkCupid. Probably most of us might be using it, I don't know. But these two individuals actually shared a data, to the open science framework that had information of over 70,000 members of that dating app, right? So the researchers actually scraped information from Cupid sites, right? They scraped out usernames of these individuals, but not their actual names. They scraped out the ages, the genders, the religion, and the personal characteristics of these individuals, as well as the answers to the question. The site asked new members to help discover prospective matches to construct their own data set. So the information which was gathered between November 2014 and March 2015 is not anonymous and it's quite personal. The only reason the researchers haven't shared users' images is that it will take up too much hard disk space according to the researchers. So anyone who has repeated a username from one site to another, who has used a name that might be traced back to them, may suddenly be severely vulnerable at that time because two individuals just scraped out data from a site which you are in, and your data is among those data that they released. So the data was scraped and uploaded in violation of the basic ethic norms that social scientists observe. So when these individuals were questioned on Twitter, the researchers claimed that the data was already public because it has been submitted on OkCupid, right? And yes, at that time, the data was public and it was submitted by OkCupid itself. And these researchers made use of this data for their own sake. But this was a case of unethical behavior with data, even though the data was public. Collecting it and sharing it explicitly was not right at all. So hence what this means basically is that these data were in the public space, but they were not protected enough. There were no privacy protections to this data as to the information, right? Because some of the information that were released by this data or by these individuals could be retraced to the owner, and which renders the owner vulnerable at this time. So in conclusion, data privacy for increased data protection is an important topic for discussion in today's world. Organizations and companies using data and implementing data science must handle that data with respect for its privacy. Using the best practices outlined here will help your organization create a baseline privacy framework for becoming a responsible and ethical steward of personal data. So yeah, thank you very much for listening to this presentation. If we have any questions, we can bring them forward.